Assalamu alaikum. Uh, Starting with the name of Almighty Allah. So in this video lecture, we will be discussing about the excavation of an NATM tunnel in PLAXIS software. So this is our first video tutorial of PLAXIS 2D 2016 version. So I'll try to cover the most of the basic concepts of PLAXIS 2016 version, and then in the coming videos, we will also discuss our about the features of 2016 version more briefly. So let's start today's tutorial, and the topic is excavation of an NATM tunnel. So let's start. What basically the meaning of NATM is. So NATM stands for New Austrian Tunneling Method. It's a well-known technique that is also known as sequential excavation method. Means the excavation is carried out in multiple sequences. So that is why it is also known as sequential excavation method. NATM is a technique in which ground exposed by excavation is stabilized with shotcrete to form a temporary lining. It means for in NATM technique, we perform the excavation in steps, and then those steps are described over here. So why this technique is preferred over the other techniques? Because it has many economic advantages as well. So these are the steps in which NATM excavation is carried out. So you can see first the drill is performed, then the charge, and then blast, and then mucking. The mucking means after the blast, the material is carried out in trucks or loaders, you can say. So this procedure is called mucking. Then the first shotcrete is applied for the temporary support, you can say. So these are the steps in which the NATM procedure is completed. I'll not be explaining too much regarding this. You can read this topic on your own. So a little introduction regarding NATM is explained, has been explained, just to give you the know-how of NATM method. So this is the problem that we will try to model in PLAXIS 2016 version. So you can see here the top layer, clay siltstone, and then clay limestone. In this video, we will also discuss the new material model, that is hook and brown model. So we will have a little bit introduction of that model as well. So we will model this thing in PLAXIS, and then we will discuss the material model. So what are the objective of modeling this? So modeling the construction of an NATM tunnel beta method has been explained in this video, using gravity loads to generate initial stresses. So basically in this video we will generate the gravity loads. We will use gravity loads. Gravity loads are used when there are non-homogeneous soil layers. The soil layers are not completely horizontals. So in this case we use gravity loads. So application of hook and brown. Firstly, let's go towards the software, and that software is 2016 version. Yes, firstly start a new project, and I'll name it as NATM. Then you will have to go to the model. Now it's very important to select the coordinates or external boundaries of the model. So you can see here -50 and 0 in the y direction, and then in the here you can see the 50 meter here and 50 meter here. So what we can do is we have x minimum, that is minus 50, and what is x max is 50, and then y minimum and y maximum. Y minimum is 0, you can see here in the model. This is y minimum and this is 0. In upward direction, if you add all these dimension, and you will get 35. So from 0 to 35 it is in positive direction, so we will put x max as y max as the 35. So this is how we can put the boundary external boundaries, so coordinates. So you will not be dealing with these parameters in this topic. So I will just click OK. Now the next step is to create the boreholes. The next important step for this version, I will click over here, create boreholes. Now the most important thing we will be discussing here is how to create boreholes. So boreholes are created to define soil stratigraphy. So firstly, as you can see in our problem, we have 3 soil layers. So I will define add the one soil layer, add the second and third. Now as I have to define boreholes, so I will define 3 boreholes, one here, second here and third here. How? Let's see. For adding the borehole, I will go to here and will click borehole add. Here I will add the second borehole, that is at minus 14. Minus 14 means here. I will add the second borehole here, like minus 14 over here. Okay, the second borehole is added. Now the next borehole I will add. Where? I will add over here, minus 7 here. So I will add minus 7. Okay, so what is the location of first borehole? I will click over here and I will add minus 22, the location of borehole. So now I have defined 3 boreholes, one here, second here and third here. So these boreholes will automatically include all the heterogeneity, means all the 3 layers. How? Let's see. I'll define now the coordinates of the first borehole. So first borehole is starting from this, having y24 and bottom as 24. So I will assume that there is 0 thickness, like 24 at top and 24 at bottom, because I am starting from here. So I will assign the coordinates like 24 here and 24 top and 24 bottom. Now the next, from here I will reach to this point. So what will be the coordinates? 24 and 11. 24 at the top and 11 at the bottom. So I will just put here 11. Now for the third one, you can see the third one is starting from 11 and 11 top coordinate is 11 and the bottom coordinate is 0. So I will just click here the 0. Now the first borehole is defined. For the second borehole, I will be starting from the for the second borehole that has the location of minus 14. So I will put the coordinate that is you can say 30. So I will put over here 30 because I am starting from this point. You can say top is 30 and bottom is 30. Now I will start from this point. So it is 30, it's 30 as well. Now I will reach up to 11 from this point to this point. Now the top is 30 and bottom is 11. So here I will put 11. The next is for the third layer. I have the top at 11 and bottom at the 0. So I will not change it. Now for the next one, you can see here the top is 35. Top is 35. And what will be the bottom of this layer? This is the most important point over here. Now at that point, top is 35 and bottom will be 30. Yes. And now the next one is 11 and so on. So this is how we have defined the soil stratigraphy using boreholes. If you see this tab, you can see all the things have been explained clearly. So this is how we can define the soil stratigraphy. Now we have to define the material properties. So the next slide, we will be discussing about these Hook and Brown model. Let's see. We will click over here, material, then soil and interface, new. Now here we have the material properties. You can see here the top layer is having the material model that is hardening soil model. I have explained this hardening soil model a little bit in my previous videos of V8 version of PLAXIS, so you can check that video for the more explanation. Now the model behavior is drain, and unsaturated unit weight is 20 and saturated unit weight is 22, and initial void ratio is 0.5, and rest of the parameters are given over here. So I will just be putting these values. I will add these notes in the description of the video so you can practice as well. These notes I will modify these notes as well, so you can check these notes in the description of the video as well. So using these material properties, I will be using these material properties in the PLAXIS software. Like first layer is, I will give it a title of top layer. Then I will change here the material model that is hardening soil model. So hardening soil model is being selected from here as hardening soil model drain behavior. And in the next step here you can add the unsaturated unit weight, that is 20 here, and 22 is the saturated unit weight, and rest of the parameters here are same. Now I will jump towards the parameters. Now in parameter I have to define E50 ref. Those who are not well aware of these parameters, they can check my previous videos of V8 version. I have explained these as well. In lecture 8 probably, the simulation of triaxial test. So I have explained these parameters very clearly in the previous videos. So what is E50 in the properties is 4 into 10 raised to power 4. So it is simply 1, 2, 3, 4, 40,000. Yes, and rest of the parameters are are automatically calculated. I have already explained these things as well, because E50 and E odometer are approximately equal, but EUR unloading reloading stiffness modulus is basically 3 times of E50. So the complete explanation is given in lecture 8 of V8 version. So the next step is to provide the material properties, strength material properties, and that are given as 10 and 30. So question is 10 kPa or kilonewton per meter square, and 30 is the angle of internal friction. Rest of the parameters are same. I will click OK. Now the top layer is defined. The new one here, the next layer is clay silt stone. Clay silt stone. And now I will be selecting Hook and Brown model. So let's discuss a little bit about this Hook and Brown model. So what is Hook and Brown model? Hook and Brown model is used for rocks mostly for failure envelope. So here is some little bit introduction of this Hook and Brown model. You can also read this Hook and Brown model on your own. I will be giving you a little explanation regarding this Hook and Brown model. So what are the assumptions of this model? You can see here it is in terms of principal stress is empirical failure criterion. It is an empirical failure criterion applied for intact rock and rock masses. It is only applied for intact rock and rock masses. So when you have the intact rock and rock masses, you can use Hook and Brown model. You have to use Hook and Brown model in that case for rock masses, intact rock masses. So it is a non-linear relationship between axial stress or confining stress sigma 3 or principal stress, you can see. So a more explanation regarding this Hook and Brown model you can see here. The Hook and Brown model have too many modifications, like you can see here in these notes. I will be providing you these notes in the description. The first the concept of this model was just started in 1980. You can see the formula. Then there was original Hook and Brown failure criteria, that was sigma 1 is equal to sigma 3 plus square root m sigma 3 sigma ci plus as sigma ci. So what is sigma ci? And m is a constant that depends upon the characteristic of rock mass. It is 0.001 for highly disturbed rock mass and 25 for hard intact rock. Then s is a constant depending on the characteristic of the rock mass. Why am I explaining these s, m and so on? Because these properties will be used when we will have to provide the properties in the Hook and Brown model. So that is why this needs to be understood. So 0 for jointed rock mass, 1 for intact rock mass. And sigma ci is uniaxial compressive strength of the intact rock material, and sigma 1 is major principal stress at failure. So then there was an updated Hook and Brown failure criteria that was given in 1988, and you can see here the m and s constants will have to be defined according to this formula. mi exponential RMR, it depends upon the RMR, and M value of intact rock mass having GSI greater than 25, and you can read it on your own. It's very easy, not that difficult. Disturbed rock masses that are having GSI, geological strength index. Basically GSI stands for geological strength index. That is one of the classification type of rock strength. So same here, you can see. Then these are the table from which we can extract the value of m and s based on the geological conditions of the rock. Then you have the modified failure criteria, in which there is a sigma 1 prime is equals to sigma 3 prime plus sigma ci m and sigma 3 prime sigma ci and e. So the parameters and the properties are given over here. Then this table can be used, and then the generalized Hook and Brown criteria in 1995 that depends upon, that uses the value of GSI. You can see here GSI. Now I hope a little bit explanation regarding this Hook and Brown model has been given to you. Now we will move towards this, and here you can see the material properties, like Hook and Brown model drain 25. 25 is the unsaturated and saturated unit weight. We will use now 25. 25, rest of the parameters will be same. Now go to the parameters and we have these properties, stiffness, and we have the stiffness and the other properties like the stiffness, the Young's modulus for this is 1 into 10 raised to power 6. So 1, yes, and 0.25 is the Poisson's ratio. Then sigma Ci is the uniaxial compressive strength of rock mass, siltstone. We have in this property that is 2.5 into 10 raised to power 4. And Mi, I have explained it as it is a constant value that depends upon the characteristic of the rock. So that is why it was necessary to give you a little bit explanation of Hook and Brown model criteria. It is 4. It is 4. GSI geological strength index is 40, and D is disturbance factor. So the disturbance value for this is 0.2. It usually ranges from 0 to 1. 1 means it's very disturbed rock mass. So the rest here you can see these properties. No dilatancy parameter in this. We have dilatancy parameter that is 30 and 400. 30 and 400. Now all the properties have been defined. Now you can see here it is, we have to go for interfaces, that is interface value is 0.5. I have already explained this. We will have to select manual and it is 0.5. Yes, okay. Now the second layer, clay siltstone, is being defined. Now we will have to define the third one, that is clay limestone. Clay limestone. It is also Hook and Brown model. So we have this Hook and Brown model. The unit weight for this is 24. The parameters are like, we have the stiffness that is 2.5 into 10 raised to power 6. And we have the Poisson's ratio that is 0.25, and the uniaxial compressive strength in that case is 5 into 10 raised to power 4. 5, 1, 2, 3, 4. What is M constant value for this is M value is 10, and 55 is the GSI value. This is 10, 55 is the GSI value. Disturbance factor is 0, it's not disturbed. And then this value is dilatancy parameter is 35 and 1000. It's 35, it's 1000, and rest of the parameters are same. Now all the three layers have been defined. Okay, now I have to assign the properties. So from here you can select the top layer, Yes, and here you can select the clay siltstone, and here you can select the clay limestone. So in this way we have defined and assigned the material properties. Okay, now it has been the completion of second step.